Okay, so this, again, part two. Part two. So yesterday, the video I left you, but what we covered was how to find the actual trig function. So like if I said find secant of pi over 5, or if I said find like the secant of theta equals a certain value and you're looking for the angle, and we talked about how to do that both with and without the calculator. Now we're going to graph these. So quick, this is the stuff we covered already, and we start here. So we have graphed sine, cosine, and tangent, and what is left is cotangent, secant, and cosecant. And just like sine, cosine, and tangent, like your AP exam is not going to say, here's an equation, graph it by hand, but it will ask you to either multiple choice match it to a graph, or it will ask you specific things about the graph. So we get really specific about the graph. You will graph by practicing by hand, but then actually testing-wise, it would not be like draw by hand. Well, AP testing-wise. Thank you. Cotangent is very similar to tangent. We know it's the reciprocal of tangent. If I take and I flip all those values, I end up with cotangent. The overall, there are two differences between tangent and cotangent as far as graphing goes. And the first is the initial shape. So notice that cotangent rises to the left and falls to the right, where tangent's the opposite. The other major difference is how we find our first asymptote. The period is still pi over b, but how you find the first asymptote in tangent is setting it equal to pi over 2. In cotangent, we set it equal to pi. So we take whatever's in that parentheses, the b, theta plus c, and we set it equal to pi. And that is your first asymptote. And then after that, we treat it just like tangent. We would add the interval. The interval is going to be your period times k. And if you wanted to find actual physical other asymptotes, you can add in multiples of k. So this is the parent function of cotangent. If you look, it is undefined. If you think about cotangent, it would be undefined where tangent 0, which is on the right and the left sides of your unit circle, which would be at 0 and at pi. And it happens every half circle or every pi. So if I were to just keep going on my parent function of cotangent, I would keep adding pi or keep subtracting pi, and I would continue to find the other asymptotes. Just like tangent, the x-intercept is halfway between those asymptotes. And also just like tangent, your quarter point and your 3/4 point are where your A is marked. The difference with cotangent is at the quarter point, your A is positive, and at the 3/4 point, your A is negative. So the only differences between tangent and cotangent are the direction of your curve and where your asymptotes lie. Everything else follows the same pattern. Or pi, but let's make it easier on ourselves and make this 0. You can set it equal to either. Because it is, like the initial function is undefined at 0 and pi. You could have picked either, but obviously 0 is easier, so change that to 0. So here's our steps to graphing, okay? We find the A and the period. The period is pi over b for tangent and cotangent. You set bx minus c, or whatever's in that parentheses. This could be a plus or a minus. Whatever's inside those parentheses, you would set equal to 0, and you get your first, this is just asymptote. You get your first asymptote. If it wants to know all the asymptotes, then you would take that and you would add the period times k, or n, because that constant can be either. If you wanted to actually physically find those asymptotes, you would add and subtract the period. So when I add the period, I get the asymptote to the right. If I subtract the period, I get the asymptote to the left. You find the points halfway between each set of asymptotes. Those are your x-intercepts. You mark the quarter point and 3/4 point. That's your A and negative A. And then you connect your points to make the cotangent curve. If there is a shift up, you would do it at the end. After you found your quarter point and your 3/4 point, then I would add the shift. So if vertical shift, move after you find A. Or you can move before you find A, but after you find the intercepts. It could go either of those spots. But you definitely want to wait till after you find the intercepts, because otherwise your intercept is like on a floating line. It's not as easy to spot because it's not on your x-axis. And it could be 0. All right, we're going to go from start to finish. So it says find the period in the asymptotes, then graph y equals 2 cotangent x plus pi over 2, and find domain and range. So A is what here? 2, which means that at my quarter point I'm going to positive 2, at my 3/4 point I'm going to negative 2. My B is what? 1, so the period is pi. I would tell you that that's the most commonly missed question on your test, was what is the period of tangent? A lot of you did 2 pi over B. Okay, now I'm going to find my asymptote. So I'm going to take what's inside the parentheses, x plus pi over 2, set it equal to 0. Did I write pi in the last one? I'm going to solve, and I get x equals negative pi over 2. So one of my asymptotes is there, and then all the other asymptotes occur a period away. So I add pi, because that's my period, k. That would represent all of the asymptotes of this function. Now to actually plot that on my graph, I'm going to mark my pi over 2, or my negative pi over 2, sorry. And then if I were to add where k is 1, so negative pi over 2 plus pi, which becomes 2 pi over 2. This is a positive pi over 2. There's my second asymptote. And if I want, I could keep going to the right, or I could also go back to the left. I could take that negative pi over 2 and I could subtract the period, or 2 pi over 2, and I get negative 3 pi over 2, which is another asymptote. They would keep occurring as you move to the right or to the left, but I would say most of the time at minimum I will ask for two full periods, which means 3 asymptotes, 2 curves. Now I'm going to find the point halfway between these, because that is my x-intercept. These are easy to spot. Your x-intercept, in this case, are at negative pi and 0. If it wasn't so easy to spot, you'd add the 2 asymptotes and divide by 2. And then because it's cotangent, we start up on the left and we go down on the right. Up on the left a quarter the way in, we're going to A, which is 2. 3/4 the way in, we're going to negative A, which is negative 2. And then we're going to repeat it again. A quarter the way in, we go to 2. And 3/4 the way in, we go to negative 2. And then we connect our points. Now let's talk about your domain and range. Is your domain restricted? Yes, right? This graph starts and stops and starts and stops and starts and stops. So instead of putting in an interval notation, because that gets really weird, they usually put this in like cannot equal. So your domain would be x cannot equal wherever there is an asymptote, which is here. Negative pi over 2 plus pi k. Cannot equal there. So the equals is where your asymptote is, which is where it's undefined. The not equals would be your domain. How about your range? Is your range restricted? No, arrows point up and down, all reals, or negative infinity to positive infinity. Domain is the opposite of your asymptote. So your asymptotes are where it equals it, because that's where it would be undefined. You just put a not equals to.
So you don't have to write it in like interval notation.
No, it's weird. They won't do that. Yeah, because you can't really start, stop, start, stop. It goes on forever like that, so it wouldn't do it.
Okay.
Good so far. Unless it restricted the period. So like if it said, what's the domain on the interval of negative 3 pi over 2 to pi over 2, then you would say x cannot equal pi over 2, like that. So it could be negative infinity. No, not negative infinity. Negative 3 pi over 2 to pi, but I think that's a weird question, but maybe they could twist it like that. All right, now we get into cosecant and secant. And this is where it's so important to understand the foundation of sine and cosine, because in order to graph cosecant, you have to first graph sine. So if you look at this picture, they are parabolas that will bounce off of your maximum and minimum values of sine. So what you don't see is what happened before this. If I was to graph this by hand, I would have graphed sine. This would go here, here, and here, and here. And my curve would have looked like this. This would have been the parent function of sine. And then think about what happens to get from sine to cosine. What would I do to get from sine to cosine? If I said the sine of something is a half, what is the cosine? Cosecant, yes, thank you. 2. We flip it, right? So if I have a value that is 0, let's say, for my sine, and I flip 0, what happens? No. What happens when you flip 0? It's undefined, and undefined on a graph is an asymptote. So everywhere there is a 0 on sine becomes an asymptote on cosecant. And then think about your amplitude. If my amplitude is 1, if I take 1 and I flip it, what is it? It's still 1. So these points are shared. But then every point after that is flipped out. So then I point these up. They are little parabolas that go on forever and ever and ever and do not end. So your secant curves bounce off the maximum and minimum values of your sine curve. So if this had just said graph secant, for cosecant, because that's what this equation is, I would immediately change this to sine of theta. I would graph sine of theta. Everywhere there's an x-intercept, I draw an asymptote. Every max and min gets a point, and then I flip my parabolas off of those points. If you think about the rest of the stuff on the left-hand side there, the range or domain is all real numbers except where your zeros are, because they become asymptotes, where the zeros of sine are, because they come out as asymptotes. And the range starts and stops at your a. So in this one, your parent function is a. It goes from negative infinity up to negative 1, and then it goes from 1 to positive infinity. Just like sine, your period, in this case, it's the parent function, it's 2 pi, but in every other case, it would be 2 pi over b.
If it gives you like a question where it's like sine and then like 2 theta, would you have to flip it to 1/2?
If it asks you to describe, no, you flip nothing. You just change the actual trig function. You graph it, so you change no values, just the trig function. And then you flip it outside. So by flipping it out, like it's flipping it off of it, you're flipping all those values. Does that make sense?
Yeah.
Okay. All right, so for cosecant, we're gonna graph sine. We're gonna draw the asymptotes where the intercepts are before any vertical shifts, because then it gets super confusing. We're gonna find the zeros, okay? Which if you're doing sine, it's gonna be the first point plus a half. So the sine zeros, which is that would be your 0. This would be your 1/4 of the period, 1/2 of the period, 3/4 of the period, and the period itself, which is what that kind of means. And then bounce your curves off the maximum and minimum points. So this part is talking specifically about the zeros of the sine curve. If I asked you what the 0 of the sine curve is, instead of finding all of them, you should know your sine curve crosses the x-axis at that halfway point. If it was cosine, then the zeros occur twice, the 1/4 point and the 3/4 point. But we'll talk about that when we start to really dive in. Mm-hmm. All right, now secant, copy, paste, and replace sine with cosine. Everything else is exactly the same. So for secant, you are going to graph cosine. And then everywhere, you're welcome, everywhere there is a 0 on cosine, there is an asymptote on secant. All of your maxes flip out, all of your mins flip out to make those parabolas. So if I were to graph, again, what you don't see is underneath this, What's your cosine curve?
All of those brothers could reflect if there was a negative in front of them.
Correct. Yeah. So all the same, great question. All of the same things that happen to your sine and cosine curves can happen to the secant curves and the cosecant curves. There can be a reflection. There can be a vertical stretch, all that stuff. I would say you can do everything, all the reflections, the period shift, obviously you'll take care of anything like that. You can do all of that, then find your curves. The only thing you want to do after you find your curves is like a vertical shift. I mean, after you find your asymptotes. After you find your curves, you're done. But after you find your asymptotes. All right, so we'll graph cosine. We'll draw the asymptotes where the intercepts were before. And this time, like we talked about, sine is halfway. For cosine, the zeros are at the quarter point and the 3/4 point. And then both the curves go off of the maximum minimum points. All right, so let's do one of these. Find the period in the asymptotes, then graph 2 secant 3x plus 1. So what do I change it to first? Sine. This would be 2 sine 3x plus 1. So what's your A? Which means that's your amplitude, right? Because amplitude would just be the absolute value of A. What's your B? 3. So the period is 2 pi over 3, because it's 2 pi over B. And this plus 1 does what? Vertical shift. I'm going to take the period and I'm going to multiply it times, the very first one would be the period. And the very first one would be 0. And then the second one would be the period times a fourth, the period times a half, the period times 3/4. So first one is 0 because there's no phase shift or horizontal shift. The last one is the period 2 pi over 3. And then I simplify these to here, pi over 6, here, pi over 3, pi over 2, and 2 pi over 3. So my 5 key points are at 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. Now, for purposes of drawing by hand, we'll actually, you can literally white out the stuff on your x-axis and change it to match what you need to do. But you're welcome. But let's say this is a multiple choice question. This would be really shrunk, like horizontally, right? This would be squished from both sides because our normal curve goes all the way to 2 pi, it goes from 0 to 2 pi. And this one is going only to 2 pi over 3. So the whole thing happens with even smaller than pi because there would be a horizontal shrink in this case by a factor of 1/3. So it would take 1/3 of your normal time to complete this. All right, so I'm gonna ignore these and I'm gonna plot just so that we can get the visual on it. The 5 that we found. So 0, we're gonna make this pi over 6, we're gonna make this pi over 3, we're gonna make this pi over 2, and we're gonna make this 2 pi over 3. 5 key points. And our amplitude is 2. And we're graphing sine. Where does sine start? Amplitude or 0? 0. So we start here. We go up, down, down, up. So before the vertical shifts, it's there. If there's a vertical shift, you want to find your asymptotes before you do the vertical shift. So I would draw my asymptotes now. 1, 2, 3. And then do your vertical shift. So everything shifts up 1. And then do your curves. Now, obviously, this pattern continues on forever and forever and forever, okay? But ideally, if this was multiple choice, you would be able to continue that pattern on. You should be able to spot it. I would say by just knowing your asymptotes, your shift, your amplitude, that kind of stuff, you should be able to differentiate. If this was multiple choice, they would throw in there a secant curve to throw you off. They might even throw in there a tangent or a cotangent curve to throw you off. Or a shift in up or down in the other direction, that kind of stuff. Questions so far? All right, see if you could do it on your own. All right, so first of all, let's talk about like what's happening if you were to describe these transformations. The negative on the front causes what? Good, a reflection over the x-axis. What's the 3 cause?
A stretch.
A vertical stretch by a factor of 3. What's the 2 cause?
A phase shift, right?
The pi over 2 is your phase shift, right? The 2 on the front would be a period, yeah.
Oh, I thought you said 5%.
No, sorry. So that would be a horizontal a horizontal dilation by a factor of a half. Good. Then the negative pi over 2 on the inside causes a shift to the right, pi over 2, right? In this case, it causes our phase shift. So our A is negative 3, which means we're going to flip this upside down, okay? But the amplitude itself is 3. The B is 2, so the period is 2 pi over 2, which is just pi. And then there is a phase shift that will happen by adding pi over 2. So now I'm going to take my period, which is pi. I would multiply it. Well, the first one would be 0 initially. And I would take pi, multiply it times a fourth, pi times a half, pi times 3/4. And then the last one would be pi. And to each of these, I am adding pi over 2. And I get pi over 2. This would be 2 pi over 4. So 3 pi over 4. This would be 2 pi over 2, which is pi. No, you're going to the right. It's opposite sign. Yeah. This is 5 pi over 4, and this would be 2 pi over 2, and this would be 3 pi over 2. So now my first key point, I can keep this if you want, like the pi over 2 can stay there, but then you can adjust these. Pi, 5 pi over 4, 3 pi over 2. No, if it wasn't adjusted, that it would happen like squished in there. And then because it's a 3, my A or my amplitude is 3. So I'm going to go up and down to there. But it is a shift. This is cosine, and cosine typically starts at your amplitude. So it would have started here, 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 here. If it was a positive 3, it's not. It's a negative 3. So we start at the negative amplitude. We come up to 0, up to the amplitude, 0, and down again. And there's my cosine curve. Now again, if it had kept going, it would have looked like this if you needed more asymptotes. But because as it is with cosine's natural curve, you're only going to get one set of asymptotes. If that's not enough information, you kind of eyeball. I don't need it to be specific. Eyeball these curves to drop down, and then you add your other asymptotes. And then your parabolas are going to bounce off those curves. Domain here is x cannot equal where your asymptotes are. Your asymptote is at 3 pi over 4 in this case, plus that happens here, it happens here, it happens here. So it happens every half period, which means if I take that period divided by 2, it happens at every pi over 2k. So that's where cotangent and tangent are different from secant and cosecant. Secant and cosecant asymptotes happen every half period. And then your domain, that is your domain, and then your range would be all real numbers. No, oh my goodness, sorry. Your range goes from negative infinity up to -3. It includes -3 because that is a point. And then it goes from 3 to positive infinity. So main and range on cotangent and range on tangent and cotangent are all our numbers, but on secant and cosecant, they're going to be restricted.
How'd you got pi over k?
Because it happens every half period. Like if my period, if it goes from here, let's say it's from here to here would be 1 period, right? Then the asymptotes happen 1 in between there. So it's every half period. Yep. Oh, that was early. Okay.